So hello everyone, this is probability and stochastic processing, homework 8 and question 2. So in this questions, it has 4 parts, and in the first part, it requires us to find the probability xt equals to 0, equals to 1. From the question we know that it belongs to the Poisson distribution. So firstly we can list the formula as this, as the Poisson formula. And we also know when xt equals to 1, n is odd in 0 and t. So the probability of xt to equals to 0 is equal to 1, n is odd. And then we can take the parameters into the Poisson formula, and as k is equal to odd, we can substitute the parameters into this function, and so we can get the line like this and this one. From this part, we can know that from the lecture notes we can know that it belongs to the hyperbolic function. So this part is equal to this formula. So this is the final result. And then we go on to the second part. In the second part, it requires us to find the expected value of xt. So firstly, as we know that when the xt equals to 1, the probability is listed as the first part, and we need to derive when xt equals to -1. So also from the lecture note we know that when xt equals to -1, the probability is equal to this function. So the expected value of xt is equal to 1 times probability xt equals to 1 and plus -1 times probability when the xt equals to -1, the probability. Then we take the results, substitute the results into the parameters, and so we can derive this function. And we know, and also we can, from the lecture notes we know that we can get the hyperbolic function as this part. We know that this formula. So we can take these formulas into this function, so we can finally get the result is equal to minus exponential to the power of -2 times lambda times t. So this is the final result of the second part. In the following, we come to the third part. In the third part, it requires us to find the autocorrelation. From the definition, we can from the definition of autocorrelation, we can list the function like this, and then we can simplify for the following, and as this function, it is firstly we need to assume that T1 is larger and equal to T2. So we can get this function. Then we can take the parameters we have derived above, and then substitute into this function, so we can derive the formula like this line. Also use the hyperbolic function we have listed above, so we can derive the result as this line. It's equal to minus exponential to the power of minus 2 times lambda times T1 minus T2. Also, when T1 is smaller than T2, the final result is equal to this part. So, in summary, we can get the autocorrelation is equal to this part, minus exponential to the power of 2 minus 2 times lambda times absolute value of T1 minus T2. So this is the third part. And for the last part, it requires us to tell whether xt is one size stationary. So from the definition, if xt is WSS, the expected value of ext is equal to a constant. Well, we know that from the definition. Whilst in this question, in the second part, we have derived the expected value is that it is equal to the minus exponential to the power of minus 2 times lambda times t. It is not a constant, so we know that xt is not WSS. So this is the second part, the second question.